This is Euclid Book 9, proposition number 20. And it says prime numbers are more than any assigned multitude of prime numbers. Here's your diagram, folks. Okay, let's go through this. Let A, B, and C be the assigned prime numbers. All three of them are going to be prime numbers. Not prime to each other, they're going to be flat out prime numbers. Like, you could say 2, 3, and 5. All three of those are, well, okay, scratch that. Let's try 3, 5, and 7. All three of them are prime numbers, okay? I say that there are more prime numbers than A, B, and C. For let the least number measured by A, B, and C be taken, and let it be DE. So, let's say we have 3 and 5, okay, and the least number that is going to be measured by 3 and 5, if I'm correct, will be 15. Okay, because I can't think of any number that is less than 15 that will be able to be measured by both 3 and 5. Okay? And let the unit DF be added to DE. Okay? So, all right. So then, okay, so first of all, DE is the least number, okay? So, DE, believe it or not, is going to be the least number. It's going to be able to be measured by both A, B, and even actually C. Isn't that nice? Now we're going to add a unit called DF to line DE. And we all know that a unit is 1. Okay. Then EF is either prime or not. First, let it be prime. Then the prime numbers A, B, C, EF have been found which are more than A, B, and C. So if we say that the length of EF is just as prime of a number, say like it's 11 or something like that, then we can say now you have 3, 5, 7, and 11. Now you have more prime numbers. Okay. Next, let EF not be prime. Therefore, it is measured by some prime number, which is by Euclid Book 7, proposition number 31. Let it be measured by the prime number G. Okay? So, now we're going to say that EF is not a prime number, but G is, and it's going to measure EF. Okay. I say that G is not the same with any of the numbers A, B, and C. For if possible, let it be so. Now A, B, and C, we said, measures DE. Therefore, G will also measure DE. But it also measures EF. Therefore, G, being a number, will measure the remainder, the unit DF, which is absurd. So now what we're saying here is that if G measures DE and G measures EF, so here we go, G measures DE, and now we're going to say that G measures EF, then G would also have to measure DF, which is absurd, because nothing measures 1. Therefore, G is not the same with any one of the numbers A, B, and C, and by hypothesis, it is prime. Therefore, the prime numbers A, B, C, and G have been found, which are more than the assigned multitude of A, B, and C. And that's the whole proof. I will tell you more in my next video. Stay tuned.